I will tell you that
Yep.
if I was given this problem, I would have done the exact same thing you did. I would have just done
Okay.
it faster. That's it.
Hmm.
You're just so basically my number one feedback to you right now is be faster, but we're gonna talk about what it takes to get faster. So let's actually
Okay.
start. Let's actually look into this.
Hi.
Oh
Hello.
hey, yeah, I can hear you now. What's up?
What's up?
Nothing
How you
much.
doing?
I'm doing good. So,
Thanks for
hmm?
thanks for doing this.
Yeah, for sure. How'd you hear about me? Was it like where'd you get the link from?
I'm in the
Oh, I gotcha. I gotcha. So,
yeah.
so tell me a little bit about yourself. Tell me why you're here, what you're hoping to get out of the mock interview, where you're at in the interview process, and so on.
Okay. Yeah. My name. I graduated with a bachelor's in computer science in December,
Hmm.
and so I'm still looking for like new grad roles or like junior engineer roles. At the moment, in terms of like preparation for like interview process, I've done like a decent amount of like practice on lead code and like broking, but then I still feel like I'm not that like I don't come up with solutions quick enough, and I still get stuck like kind of often. And I'm hoping to get more experience like doing interviews and like just knowing how because I'm not that familiar with like the whole like interview process. Because I've only had like 3 or 4 interviews so far out of like the applications I've applied like jobs I applied to.
Hmm.
So yeah, I'm hoping to get more experience in like doing this type of like interviews because like some interviews didn't really do like data structure questions, so it didn't really give me any chance to practice. So I'm just hoping to yeah get more experience in doing this type of interviews.
I see. Oh wait, hang on. Let me get a piece of paper. Let me make a note of this.
Yeah, for sure.
Okay, so recent grad,
Yep.
had 3 to 4 interviews done. Not fast enough. Enough.
Yep.
Not all coding
Yeah.
structures. And junior. Okay, junior dev.
Yeah.
Cool.
Yeah.
So these 3 to 4 companies, were they startups? Were they well known? What were you interviewing?
So I have there were like I think there were like 2 startups and two of them were like small like mid-sized companies.
Mm-hmm.
Um, so they were some of them were intern roles. The others were like junior roles. I'm still waiting to hear back from some of them. But some of them gave me like coding challenges that would take home. I didn't really have yeah. Now that when I come to think of it, I probably only had like only one of the interviews really gave me like a type of interview that's like similar to what fan companies do. The others weren't really what fan companies would do. I've had like mock interviews with like some other people, but that's about it.
Okay. So you're still
Yeah.
pretty early on. You don't have much experience with them. Okay, it's cool. You did some few mocks.
Yeah.
Tell me how that one interview went.
It started out like pretty well, and then I wasn't sure. Like, I think like the one thing too is I'm not sure how because like I know like we're supposed to think out loud, but then I'm not sure like what's like is it okay if like I just stay silent and like think about the problem for like a while. But then most of the time I feel kind of awkward just by staying silent and thinking about the issue, and like it's kind of hard for me to brainstorm like a solution out just because like I'm trying to focus on thinking, but then it I feel nervous just because like it might be awkward and like I don't know if it's okay to be silent for this long, and then it just kind of gets stuck, and it took me like a decent amount of time for me to like come up with like a solution, but it wasn't really the optimal solution. So yeah, that's kind of how it went.
Okay, that's fine. I see. It's that okay, so you are dealing with having to actually speak your thoughts out and do the whiteboard when it comes to actually performing. Okay. Well,
Yeah,
how do you
yeah.
do in practice? What is your on a scale of 1 to 10? How proficient are you? If I were to just say, "Hey, here's a pencil paper, solve this leak code problem. I'll be back in 40 minutes to see if you got the solution."
I think if I'm given like a space and time to do it by myself, I think I'm at depending on like the type of problem, I could be like a 4 to 7. If it's like problems like arrays or like breakfast search and like problems that I'm familiar with, I could do them like pretty quick. I usually just like try to look at the problem and like kind of write out the edge cases and write out a few examples and like go through them and then try to think of a pattern, come up with a solution and hope see if I could come up with like a better solution and then code it out. But if it's like a DP problem or like a recursion, I'm not that good at like DP or like some greedy approach problems. So those I might be like a 3 or 4. But if it's like typical common problems, I could be like a 5 to 6.
Okay, that's interesting.
Yeah.
Well, I mean that's also pretty typical. Um, Most of the time you're not even going to be asked a dynamic programming question, and that's usually tacked on at the end of a problem that they don't expect you to solve. Um, it's like a bonus, and I think I've only been asked dynamic programming like once or twice in all the interviews I've ever done. So I'm not too concerned about
Oh,
that.
okay.
That's something you can always learn on your own.
I
Usually when
see.
people come to me for help, it's usually because they're stuck in improving their efficiency or their time or getting the optimal solution. That usually they've already gone through the interviews a few times and they just get stuck. They don't know how to improve. So have you seen like some of the coaching videos that I've posted?
No, I wasn't quite sure where the videos were. Like I saw that you mentioned in a comment that to check out your coding videos, but I wasn't really quite sure where those videos were.
Okay, I'll send it to you at the end.
But
But
okay,
basically, what
but
happens? Sorry, go ahead.
I did read the article you posted on Google Docs, the 50-page one.
Mm-hmm.
Yeah.
What What'd you think? Did you like it? Did you actually do anything about it?
I actually think it's pretty good. It kind of lays out what people should really do, like really should do, and that's what I've been trying to do as well. Just trying to put in practice time and being able to reach that proficiency of like just looking at a problem and knowing the optimal solution
Mm-hmm.
right off the bat.
Okay, yeah, so you're aiming in the right direction. I'm going to tell you this, that for the coding
Mm,
interview, what people get wrong is that they think it's like a college exam where you regurgitate back the runtime algorithms and then maybe do it on a toy problem. It's basically not that at all. It's how you
mm,
perform with
yeah.
that and how efficient you are. So the key is how efficient you are with your time. Um,
Okay.
and recognizing patterns is one way to improve the efficiency because it's like front loading all your work ahead of time instead of trying to derive it on the spot. Because you're only
Mm,
given like 40 minutes for the interview, you want to make every moment count. So ultimately, what is left once you strip away everything is how your consistent approach, how you approach the problem, and how efficient that process is in getting the solution for any given particular coding interview, if that makes sense.
yeah, that makes sense.
Yeah, you're
It's
not trying to
just
derive something on the spot.
okay. Yeah, yeah. It's just like I don't know. I just feel like I'm sometimes I feel pretty decent and confident when it comes to like certain types of problems, just because like I've like solved like similar problems and stuff.
Mm-hmm.
But when it comes to like problems that I've never seen before, or like just like for example, like I think problems that have like 2D array matrices, um, sometimes I kind of have like an issue. I kind of get stuck on those like pretty easily as well. So it's yeah, I'm not quite sure where I stand on like the scale in terms of like the interview preparation progress.
I see. Okay,
Yeah.
so if it's like a problem that you can't deal with, that is a mechanical thing that you just straight
Hmm.
up need to practice. I can't help you with that.
Yeah, yeah, yeah.
But
I
how
understand.
confident are you with trees? Like
Trees.
binary trees, yeah.
I would say I'm comfortable with them. Yeah.
Okay. So, let's see if we can try figuring out what the problem is with your thinking. You mentioned that you feel like sometimes you're just slow at it. So,
Yeah. Like I yeah.
mhm. I'm thinking that you probably don't have enough
Yeah.
practice in general. How many leak code questions have you
Hmm.
done?
Let me go on it. Let me go on and check it out.
Yeah, just
Just
ballpark
right
it.
now. It I've done like maybe 60 to 70.
Hmm. That's usually not
Oh,
enough.
actually 80. Yeah.
Yeah, it's usually not enough.
Yeah.
Usually people start getting comfortable at around 150.
Okay. Yeah,
They can get up
that's a
to
good
it.
thing
They
to
can
know.
do it in 100 if they or less if they're doing it deliberately. That's actually what I did. But anyway, without further ado, let's get into it. So I'm gonna share
Okay,
with you
for
the Google
sure.
Docs.
Okay. Yeah. I've been focusing more on like broking
Mm-hmm.
coding interview.
Do you have any interviews lined up?
Um, I might I might get a interview from TikTok just because I had someone refer me, but that he only did it like a few days ago, so I'm still waiting to hear back if any.
Yeah, don't bank on that, especially with very junior dev. It's like
Yeah,
those are almost hit or miss. And I think
yeah,
it's also really important to at least tell you because just to taper your expectation,
mm,
expect a anywhere from a 1 to 2% response rate.
yeah, okay,
Just
yeah,
that's absolutely normal.
yeah. That's
Just
pretty much what's been happening. Like I applied to like so far I applied to like I think 70 places, and only like five or six got back to me. And I still have some referrals I could use. I do have a friend who could get me a referral at Google, but I just didn't want to use those first just because I don't feel I'm ready enough.
that's fine. That's totally reasonable. I sent
Yeah.
you the link. We can talk more about
Okay.
the thing after. We can talk more about it afterwards. Do you just need the coding interview practice, or do you also
Okay.
need the resume review?
If we have time and if you don't mind, I'll be happy to show you a quick. I can show you my resume real quick
Sure. I'll just
as
go
well.
over it
Yeah.
and then just edit the shit out of it as I usually do. Don't
Appreciate
worry.
it.
So you're pretty. So how this works? So I'm gonna spend 40 minutes. 40 minutes on a question. See how you
Okay.
do, and then we're gonna watch that replay. And I'm gonna tear you apart.
Okay.
So So the problem you're going to be given is I want you to compute the lowest common ancestor in a binary tree. So any two
Okay.
nodes in a binary tree has a common ancestor. So for any two, so like that could be the root, that could be anything. And the lowest common ancestor of any two nodes in a binary tree is the node furthest from the root that is an ancestor of both nodes. Do you follow me so far?
Yeah. What was
Let me know
common
if you've seen this
ancestor?
problem before.
Yeah, I've seen it, but I've never really done it yet.
Cool. Now here's your chance to do
Yeah.
it. So this should be fairly easy. I'm going to expect you to do it in 30 minutes.
Okay. Compute. So any two its nodes in a binary tree. So the input would be two nodes. Is that correct?
Well, yeah, are you sure?
Wait, wait, no. Any two nodes in a binary tree have a row. So the input is a tree, a binary tree, and two nodes. Is that what I'm given?
Yeah. So your
Okay.
inputs are going to be two nodes, and then the binary tree.
Okay.
That's correct.
Okay. And I'm supposed to output one node, which is the lowest common ancestor of the binary tree, right?
Correct.
Okay.
Keep in mind these nodes do not have parent pointers.
Okay. And the structure of the node would be I'll have so basically I'll have a node, and then each node will have a left and right
Mm-hmm.
and a value as well, right? Those are like the three things a node will have.
Yeah. Let me just. Yep. Left,
Okay.
right value. Yeah.
Okay. Um, common. And the two nodes given, are they going to be leaf nodes or could they be like any nodes around the tree?
Any node that exists in the tree, you're welcome to assume that they're valid.
Okay. Assuming like those nodes would be valid, I guess like the first thing I would do is probably have to find those two nodes, and I'm trying to figure out if DFS or BFS would be appropriate in this case. Hmm. I guess one way I would do it is probably do a DFS on the tree to find two of the nodes
Okay.
and probably have like an so when I do find one of the nodes, I would save the path of
Mm-hmm.
it, probably an array.
Okay.
Yeah, and yeah, that same goes for the other node, and then I could probably traverse the two arrays um, until I find the lowest common ancestor.
Okay, what do you imagine that would look like? Give me an example.
Oh,
You can just type
mm,
it out here.
okay, so it could be a um, three, and then it could be a 4, 5, and then 6, 7.
So, am I
So
okay? Yeah, sure. Go ahead.
yeah, so so okay, so if the two nodes are 4 and 5,
Mm-hmm.
then I'll do a DFS going 1 to 2 and then 4, and then once I find 4, I'll have an array of 1 to 4, and same goes to the other one. I'll do DFS and then I'll find it at 1 to 5, and I'll save those two arrays.
Mm-hmm.
Then I'll traverse both of the arrays from the end,
Mm-hmm.
and once I find a matching node, that's probably the lowest ancestor because it's the furthest from the root, which is the beginning of the array.
Sure. That makes sense.
Yeah.
Now,
Yeah.
you do make a few assumptions here.
Okay.
Um, what's you're assuming that the value that you can use the values to do this.
If if I store the whole node into, if it's an array of nodes, it could be, I could be comparing the pointers, basically the addresses of the elements in the array.
Mm-hmm. That's fair. Now, what do
Yeah.
you think the runtime of this would be?
So doing a DFS twice. So I mean, wait, let me see. Um, worst case, I would, yeah. So worst case, I'll probably have to go through like all nodes. So it'd be log of n. Doing it twice, it's still log. I mean, yeah, O of n, and but I'll need two arrays, so the space would be O of n as well.
Hmm. And
Yeah,
then so that's those are two DFSs, and then you do the space, and then you create
yeah,
the arrays.
and
Then you have the last step, which is trying to find the common path.
comparing, yeah, and finding the common path would be traversing both. Assuming I'm using a two pointers, it would still be O of n.
Two pointers.
Yeah, I mean to compare like the from so the two arrays, I'll compare the elements from the end of the arrays
Hmm.
moving towards the beginning.
Okay, that's okay. Let's
Yeah.
see. That does make sense. Mm,
Would you prefer like an more optimal solution, or like a better solution instead of this?
let's see. So tell me how you handle if I were to give you in this particular case 6 and 3. What do you
So if I
just
get,
entertain me? If
okay,
I
yeah,
gave you
if I
six
get
and three,
six
how
and
do you handle
three,
this? Yeah.
then I would have so I'll do a DFS and then two arrays as well. 1, 3, 6. Hmm. I would. Let me see. So the lowest common ancestor would be three, huh? Or does it has to be one in this case?
Well, which one's lower?
Three is lower.
Hmm.
Okay. So the node itself counts.
So how do you handle this case?
Okay. I guess instead of going from the uh, the end, I could probably start from the beginning, and then once I hit something that's different, then I'll return I minus one, the previous index. So in this case, I'll go one and then three, and then once I hit this one, there's nothing else left in the first array, so I'll return the index at three.
Okay.
Yeah.
So, okay. So basically, so when you've hit the end of the list, you're going to just assume that that's the lowest and eject out.
Yes. Just because I'm doing a DFS through the tree, and so once I reach the end, that would mean that's the lowest common ancestor on the two nodes.
Hmm. So then you've already told me that you take up was it you took up an order n space, right?
Yeah, for the
Can you?
race.
Okay. So you do have an answer here. And it does seem correct, at least from based on what you just told me. Now, is there a way you can get
Okay.
even a little bit better?
Ye- yes, I'm trying to. I'm sure there's like a better solution to this
Hmm.
one than this one, and I'm trying to figure out what that would be. Mm, mm, mm. Right now, I'm still contemplating if DFS would be the best solution if I would want to improve my current solution.
Mm-hmm. That's fine. Take your time.
Yeah, for sure. Thank you. I'm thinking if I would like store like the different levels of the tree if I were to do a BFS, and but then I'll have the issue of like finding the ancestor,
Mm-hmm.
even though it would be easier to find the nodes through a BFS.
Mm-hmm.
Hmm. As much as I think that there would be a there's a better solution to this one. I'm afraid I couldn't come up with a better solution than this one at the moment.
Mm-hmm. Let's
So
spend some time.
would it?
Let's spend some time on it. Okay.
Okay.
So, what do you think is more reasonable? That which have two dimensions, time dimension and space dimension that we can improve on. What do you think is going to be better? Which one do you think we can more easily improve?
I think we could improve the space complexity.
Okay.
Um, but it would, but I would still have to keep track of the nodes. So I'm probably have to backtrack on that if I were to improve on the space.
Okay.
Yeah. Let me think. Binary tree. So if it's 5, 6. I'm wondering if I could do a DFS and find like one of the nodes and then backtrack to its parent and then search the other node. If it's not possible, then I'll have to backtrack again to like the parent of the parent, and then do a DFS on that one.
But isn't that essentially what you're going to do for DFS anyway?
Yeah.
So,
Um, Okay, assuming that they would for sure have lowest common ancestor, um, I could at least improve it by sizing it down to just one array at the moment. Once I find one of it, I could do another DFS to find the second node while comparing to the first array instead of like creating another array.
What do you mean?
And so if I do find one, two, so assuming it's okay, so in this case it's so let me just list down the nodes. So it's if it's 4 and 5, I could do 1, 2, 4, and I'll start at let me see, start at one, compare one, two, 4. Never mind. I don't think that's possible in every case.
Okay, what if you tried looking for both of them at the same time? That way you wouldn't have to keep
What
a separate list.
if I look for them at the same time? Yes, I'm trying to like yeah. So I don't know how exactly I would put it in code, but like I think like a good way would be like to do a DFS to find both of them at the same time. So at each node, I'll compare it if it's equal to one of the two nodes that I'm given in the input, and say like I find both of them, then I would just backtrack to from both of them until I hit a common one.
Okay. So
Yeah,
what
but
is that?
then
What would that look like? You just give me the pseudocode for now.
okay, so summation find the something itself given node one, node two, and the root.
I mean,
So
you
I'm
can just
doing
write
it. Yeah.
pseudocode if you're not comfortable writing the actual code for it.
Okay. Okay. Yeah. All right. So I would traverse the array. I mean the tree. So I'll probably have um, let's see. So I'll have a helper function as well. So I'll have a helper. I'll just have a helper that takes in, both node one and node two
Mm-hmm.
and the root. So the fun the role of it is to compare if if the root or like the node at the given, yeah, it's okay. I'll do root. Yeah. Root is node one, or root is node two. So I'll do the comparison here,
Mm-hmm.
and then if it is, then I'm just gonna backtrack right now. In the main function, let's see. I call the helper and pass in both node one, node two, and root.
Sure. Mm-hmm.
Yeah. Okay. Backtrack. Hmm, Um, two, two. Okay, if it's not, then I'm gonna continue calling helper on root left as well as root right.
Okay.
Um, yeah, I know I don't have like the same like the function signatures are not the same, but you
It's
get what I mean.
whatever. I
It's just
understand
yeah,
what you're
yeah,
going
yeah,
for.
yeah. Okay.
So then you say you want to do backtrack. What do you mean by backtrack? What's your return value?
Yeah, that's what I'm trying to like put out. That's what I'm trying to figure out in a clearer way of putting
Okay.
it. Mm. Um, so once I find I'm probably going to return a Boolean value if I do find one of them.
Okay. So,
And yeah, and I'm trying to think of like a way to keep track of like, when I backtrack, how do I find the lowest common ancestor by having a Boolean?
mhm.
Mm-hmm.
Well, your condition is if you found one node or the other node. And so, how do you distinguish whether or not you found which one you found?
Yeah.
I mean, I think that's fine. So, I mean, we just keep
Yeah.
going, I guess. Just, yeah.
It, I guess like it, yeah, it's the only issue is like, well, I don't think it would find the same node twice. I mean, but yeah, in the case that you do give 6 and 3, then I would both stop at 3, which would be an issue. Um,
So what are you thinking right now?
I'm thinking of like how to backtrack and basically keep track of the nodes I've visited and like the once I found a node, um, how do I backtrack from both of them while keeping track what would be the lowest ancestor? Yeah. Um, I'm so yeah. I'm guessing like they each. I'll probably have need to have a left and right on like the nodes to so this is it's kind of hard to explain, but I'm
Try your best to.
thinking like yeah, I'm thinking that each node might have a left and right. Not really. I don't mean left and right nodes, but I mean like left and right Boolean flags. And if a node has left and right both of those flags true, then it would be the lowest common ancestor of the two nodes. But then uh, I'm just having trouble figuring out how to backtrack.
Okay, that sounds
Yeah.
reasonable.
So yeah, if not no, then I'll return. So yeah. Uh, so instead of having the helpers called after, I would call them before, and probably have a flag for like the left, and then the flag for the right
Mm-hmm.
to check on it.
Mm-hmm.
And this is the base case if one of the nodes matches the root.
Okay. Do you need to store any other information in the return value?
Right now, I can't think of anything else to store except for the true, just because like I'm already storing the boolean into a variable over here.
Okay.
So at each node, I would traverse the left side and right side.
Mm-hmm.
Um, at least in the case that the two nodes given are on the same level of the binary tree, I could just check, if left uh, and right a true, then the current node would be, I'll just return current node, which would be oh, current node, and that would probably be the
Okay, that's reasonable.
yeah,
Sure.
yeah.
So,
But in the case,
mhm,
yeah, in the case, I'm trying to find out a way to handle the case, if the the two nodes are not on the same level.
mhm.
So left, right, tree. Okay. Guess. Okay. I probably need in order to handle that, I probably need another variable. Or like it could be self or like I'd say mid, just because it's in the middle. Um, I'll compare, do the same comparison. If root is node one or node two. In that case, I wouldn't need that. I'll just check if left or right mid return true. Hmm, Um, yeah, so left, right, and mid. So basically left checks the left side of the current node, right
Mhm.
checks the right side, and then mid would check the node itself.
Mhm.
And I guess for the for in order to find to find the node to be returned, um, two of the three flags would probably need to be true. It could be left and right, or it could be left and itself or right in itself.
Sure.
So if two out of three of the flags left, right, mid, then instead of returning, because I'm already returning here for the backtracking, I could instead have a global variable.
Okay.
Yeah, it could be none, and then if two out of three, then the result will probably be that node. Um, I mean, yeah, root,
Okay.
and then after calling the helper function through the whole tree, then I'll just return the global variable.
Um.
So yeah,
Okay. So what does that? Where does that
I
go?
mean, so yeah, I'm gonna go through the code once, go through it once. So yeah, so say we go with 4 and 5 right now, then I will call it on 245 and 367, and 2 would call on 4 as well as 5. So at 4 it will return true. So so it will go back to 2, setting its left being true, and when it checks on 5, it's gonna return true as well.
Mhm.
So when they both backtrack to 2, its left and right would be true, although mid would be false.
Mhm.
So two out of the three being left and right being true, I would set the result to root, which would be 2 at that instance, and after calling the helper function, I return 2. And if it's the 6 and 3 example, when it reaches 3, it would set mid to true, just because the root itself. The node itself is one of the two nodes, and then when it calls on its left side, which is 6, left would return true,
Mm-hmm.
right would return false just because it's 7, and 2 out of 3 being true, then the result would be set to 3.
Mm-hmm. Okay. So
Yeah.
let's actually flesh that out. What does it look like in code?
Okay. Self dot result. So global and no. If not root, return false. Left equals to node 1, node 2, 1, node 2, root. Okay. Root equals to. So are we okay? It might be a little late that I'm asking this question right now, but when comparing, are we checking on the values, or do you want like the address or like the node itself?
Well, so do you remember what I asked you in the very beginning about the
Yes, I
values?
do.
Yeah. So
Yeah,
what do you
I do.
think? Given that I asked you, well, you just assumed that the values could all be the same for your initial solution. What do you think? Do you think that's applicable here?
Y- yes, I do. I'm thinking just in case like the tree may have like duplicate values. I think it would make more sense to compare like the address instead of the values.
Mm-hmm.
Okay, yeah. Root equals to root. Um, okay. So since these are booleans in Python, that should res become one, if anything. Um, if left left plus right plus mid to self equals out plus root alpha mid to false. Hmm. I've ran through the code once. It should be good.
Okay. So
Yeah.
the root null, sure, sure. Yeah, I think this looks right. Cool.
Okay.
So you're up to 42 minutes. Just out of curiosity, just for your curiosity, do you need like a
Mm.
break, water or something?
No, I'm good.
Okay. So then let's watch the replay. Cool. So, very briefly, just tell me how you think you did.
What was it? Sorry.
Tell me your impressions of your own performance. What did you struggle with? What did you think you did well with? That sort of thing.
Um, I think there was a lot of silence during the problem, and I guess I was really struggling to come up with a solution rather quickly instead of spending enough time to find a optimal solution. Because I think I spent like a decent amount of time doing the talking about the first solution I came up with, having the DFS, finding two nodes, and then comparing the arrays. Uh, and once I thought about finding both nodes at the same time and then doing the backtrack, I think I was struggling a lot with like the exact implementation of that method.
Mm-hmm. Okay. So basically, yeah, I gave you that hint at 19 minutes. Like, hey, what if you tried looking for both of them at once? Because you seem to be hung
Okay.
up on that. I will tell you that
Yep.
if I was given this problem, I would have done the exact same thing you did. I would have just done
Okay.
it faster. That's it.
Hmm.
You're just so basically my number one feedback to you right now is be faster, but we're gonna talk about what it takes to get faster. So let's actually
Okay.
start. Let's actually look into this. So,
Hmm.
so here's the prompt. So it's fine. I think everything up for the first 15 minutes is actually pretty reasonable. So you start with the class definition. Okay, sure. Just clarifying that's a binary tree, binary node, whatever.
Hmm.
Um, and then you mentioned like around 3:30 that you want to do like a DFS or BFS. Usually
Hmm.
that's a little bit odd of a choice, only because well, usually when people deal with trees, they usually talk about things in terms of traversal. And I understand where your thinking is coming from. You're treating the what's it called, the graph, as if it is another node. I mean, you're treating the tree as if it's just another graph.
Okay. Yeah.
And I understand that perspective, but it's also I feel like it gives you too many options. Whereas traversal, it narrows your focus, especially if you're dealing, that this is a, excuse me, this is a binary tree, not an n-ary tree with multiple potential children. You know that for sure that this is only going to have two children. So usually we
Yes.
refer to things in terms of traversal just because of that.
Okay. Got it.
It's
Hmm.
just it's a small thing, but it can add up to like a lot of it has pretty big consequences when it comes to your efficiency. But I think it kind of bites you a little bit later. But for now, let's keep going.
Okay.
So here, da 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 da. So you do the drawing, fine. This is good. I think a lot of people end up forgetting to do something like this, and the fact that you remember to do like a drawing or example to illustrate it is good. So this is you fleshing out your naive solution. I think for the first
Hmm.
doing it in 10 minutes is actually fairly good. I think you'd actually take a little bit longer, like 12 minutes. Yeah, you go up to 12 minutes here, and then you explain the naive solution. You get your run times correct. I don't have a problem with this actually. So everything in the
Okay.
first, you can consider that everything in the first 12 minutes to be actually correct. I don't think there is much else I can really say about it. But
Hmm.
where we get hung up on is around here actually. So after this, you start to sputter. I'll say you get really hung up on this idea of DFS. Why do you do that?
I at that moment I was pretty nervous and I was afraid I couldn't come up with a better solution. So I was hoping to stick with that at that moment.
No, okay, that's fine. You're like trying to iterate over a DFS. Okay, that's fine. But you definitely
Yeah.
spend way too much time on it. So if you look here, you
In,
proposed your solution at 12 minutes, right?
okay.
You're
Yeah.
already spending another like 18 minutes, 18, 19 minutes trying to test DFS, BFS. So right here is already 7 minutes that is kind of, shall we say, wasted. Imagine if you just cut this down in half. That saves you like 3 minutes out of your 40-minute interview, which is actually, it starts adding up. So say we can shave off minus 3 minutes here.
Hmm.
So yeah, at 19 minutes, I finally give you the hint. Hey, yeah, what if you tried traversing both of them at the same time? At this point, I would not pass you as a mid level. I would definitely pass you as a junior or entry level, and which is what you're going for. So I think that hint is actually perfectly okay. But after
Hmm.
this, I would have expected you to basically um, bolt through it and be able to just
Yeah.
like da 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 and get in
Hmm.
and then be able to finish the coding in like by the time the timer hits 35 minutes or 30 minutes.
Okay.
So this is my expectation for you. Let's see how he plays out. So at around 23 minutes, You finally start mentioning backtrack and recursion. You finally actually start mentioning it.
Mm.
So you notice, like for 4 minutes here, I told you what happens if you try to do it at the same time. Well, that should instinctively trigger recursion, some kind of traversal. So this goes back to what I was saying before, where you're thinking about DFS BFS. DFS
Yes.
BFS
Yep.
really limits your thinking because most of the time, you rely on external data structures to do this, like with a stack or a queue. I mean, you could do DFS with recursion, but most people don't think of DFS with recursion. I mean, you can, but you need to have that flexibility of thinking to begin with, which is why I mentioned it's probably easier just to think of things in terms of traversals,
Okay.
because that gives you more that's more like recursive thinking. But I mean, it's still doable with external data structures. It's
Mm.
just a little bit limiting. So if you could figure out a way to switch your thinking at that moment, since you've already exhausted your DFS and BFS solutions, just being able to switch to recursion in your head would save you at least those 4 minutes.
Okay.
So imagine it, yeah, imagine if you could just shave off those 4 minutes. So right now, I'll mark that an efficiency because once you understood the recursion, you already understood you need to do some kind of backtracking or return some value. So that's fine. So then here, you start considering you consider how you actually do it. You're still kind of stuck, but then at around 27 minutes here, you actually figure out, oh well, what happens if I'm given the same node twice, or if one of the nodes is the ancestor. So you right now are encountering the problem of what I like to call the potato problem. It means that
Okay.
you are what?
No, I just said okay.
Okay, so
Yeah.
what is the potato problem? The potato problem is that you have not seen this before, you don't know what it is, and you have no idea how to proceed. And the reason why I call it a potato problem is because anyone who gets put under that situation immediately acts like a fucking potato. And that's exactly what you just did here. For like from 19 minutes to 23 minutes, you don't have that intuition of switching to recursion. But once you do, then you realize, hey, wait, if I'm doing recursion, I can do backtracking. But then from 23 to 27 minutes, you basically do nothing. So that's another 4 minutes right there. So immediately, you should be already thinking about your example cases. And this is actually how you get over the potato. It's you just generate a whole bunch of examples and try to find a pattern. Like you remember reading you said you read my guide, right?
Yeah.
So in it, there are 3 steps I give when you're actually doing the problem. The first step is doing the pattern. What is the second step?
Having examples
Yeah,
to
having
test it.
fucking examples. If I can't figure out it doesn't match any pattern that I know, generate a fuck ton of examples and maybe I can pull a pattern out of there, right?
Okay. Yeah.
But in this case, it
Um,
doesn't work exactly like that. What you're gonna end up doing when you generate a bunch of examples is really just generate a bunch of cases, which actually is something you figure out like later on. So let me zoom forward, and then I'll show you exactly, and then I'll actually try to show you how the way I would approach this.
okay.
So here you begin to actually figure out slowly that hey, wait a minute, I need to actually flag these conditions. But notice here, you're at 34 minutes when you actually start
Mm.
figuring out, hey, what if I just consider every single possible case, with examples. So again, from 27 minutes to 32 minutes, that's another what 4 minutes
Yeah.
that it takes you to finally
Yeah.
realize, hey, what if I generate some cases? And then here, okay, you finally worked your way through it. Fine, I think this train of thought is reasonable. And then you finally start coding it out, fleshing it out finally in your head. And then you finally just get to coding. So you get it at 37 minutes. Yeah, you pretty much have it at 37 minutes. You would agree, right?
Yeah.
And then look how quickly it takes for you to code it. Just 5 minutes, right?
Yep.
So don't worry about like not having enough time to code. Look, once you had the idea, it took you 5 minutes to code it. It's like like out of all the things that you could possibly do in the interview, this is actually the least important. I would argue because once you have the design correct, it takes you so little time to actually write the code.
Yeah. Your newly added section definitely talked about that.
Mm-hmm.
But I was just like really stuck on it for like the longest time.
Hmm. So let's
Hmm.
actually go over all the inefficiencies that you did. So first 12
Okay.
minutes we said it was perfectly okay, but then you burned 3 minutes to try and until you get the hint. 4 minutes between the hint and then trying to figure out, oh wait, I need to do recursion. Another 4 minutes to see to figure out your examples, and then another 4 minutes to actually figure out, hey, wait a minute, I need to actually handle each single one of these cases. So in total, 3 plus 4 plus 4 plus 4, that's 15 minutes that just wasted. Which, if you shave that off, would put you under 30 minutes. In fact, let's actually cut that down in half to 7 minutes. Let's be generous. Like it takes you a while to figure it out.
Hmm.
That still puts you at 35 minutes. And with a little bit of tweaking, you could get it down to 30. But 35 minutes, I
Hmm.
think, is perfectly reasonable. And in fact, like you would probably get like a full on pass from the interviewer if you could get it to that point, and you could just like eliminate the hint as well, if at all possible.
Hmm.
I think you would just actually pass a Google interview right there for an L3.
So I have a question. So when I hit the 12-minute mark, you said everything was okay.
Mm-hmm.
I already proposed the naive solution,
Mm-hmm.
and you said I talked about the that solution up until the 18 or 19 minute, right?
You basically got hung up on DFS and BFS.
Okay, in in an actual interview, say the should what should I what should I have done? Should I have just like stopped talking about it and then tell the interviewer like, oh, okay, so that's a solution that could work. Now I'm trying to think of a better solution to figure this out.
Even if you say it, I think it's mostly just the fact that you get hung up on it is actually the problem. So it's like okay, you can make the argument, hey, this is the best I can do with DFS. Let me try
Mm,
rethinking it. And I think yeah, it's like you have one or two options. You can stick with DFS, or you
mm.
can abandon it and try something else. My problem isn't that you kept pursuing DFS. My problem is that you pursued DFS for way too long.
Okay. So if I were to stick with it, I should have just like assume that I do stick with the DFS
Mm-hmm.
solution. I should have just talked about it pretty quick after proposing it, and then get into writing the pseudocode instead of like getting hung up on it.
No, because you even writing the pseudocode for it would not have helped you because you didn't have this idea in your head. The solution that we have right here. In fact, actually, I told you that this was the more optimal solution. What do you think the
Yeah.
runtime and space complexity is of this?
So this one, space would be over just because of the call stack, just in case like it's like a skewed tree.
Sure,
Uh,
why not? Yeah.
yeah. Runtime
Even its
over as
average is
well,
still going
worst
to be
case.
order n,
Yeah.
but it's a much
But
lower
yeah,
order n than what you proposed.
yeah, yeah, that it definitely is. Just because I don't have to do like a few times.
Mm-hmm.
It's only like a one run through.
Mm-hmm. And what do you think the space complexity is?
Space would be over for the call stack. I mean, in case like it's a skewed tree,
In case
but
that's the
I
most
think
extreme case. Talk about
yeah,
order.
yeah. But
Big O is average.
okay, on the average case, I would say it's log of n.
Try again. I mean, yes, technically, but actually, no. Yeah, you're right. But we can express that a little bit better.
Okay, so yeah, just because like traversing like a tree to a leaf, the height of a tree is log of n, and then
Mm-hmm.
so on average, assuming those are like two leaf nodes, I would do two log of n,
Sure.
But if it's like not, yeah, if it's like a middle one, like the 6 and 3 example, it would
Mm-hmm.
still be close enough to two of log of n.
Sure. But what I was trying to really say is you could just say it's order height because order height is log of n, but it's just like kind of
I see.
it's just me being a little nitpicky. Your answer's correct. Don't get me wrong. It's just me
Okay.
being making sure that you're actually aware that is the case.
Hmm.
So so
Okay.
actually okay. So your time space complexity analysis, fine. I don't have a problem with it. Um. So yeah. So basically, what the point I'm trying to hammer home here is
Hmm.
know when to drop your losses and try something else. So again, if you shaved off 7 minutes, you basically would be moving on to the next problem. And the next problem I would have asked you is how does your is probably not as a non-coding one. It would just be how does your solution change if I gave you parent pointers, and then I would just ask you to talk through it. I wouldn't ask you to code it. If you did that, 100%
Okay.
guarantee, 100% guarantee you pass the interview.
so a lot of like interviews they do that. So if you finish on like fast enough, they would propose like a different situation to that same problem, and then you usually don't have to code it out. You just kind of talk about it. Is that right?
I mean, that's usually how I do things. That's how a lot of interviews go. Unless the problem is
Okay.
significantly hard enough, then they'll
Hmm.
ask. They'll make you do it. But this actually, I think, it's more of a medium slash easy. So I would have
Hmm.
reasonably expected you to just go to the what's it called, the next problem actually at this point, which is why I say, hey, if you got to 35 minutes, so let's actually consider the schedule of a typical interview. So you have
Hmm.
let's say you have about four, let's say not even 45. Let's say you get 50 minutes for the interview, right? Five
Okay.
minutes for the tell me more about yourself, 45 minutes, right? So then, boom, let's say you get to 35 minutes on the main question, 10 minutes to talk about the what's it called, the problem, maybe 15 is the interview. The next problem is the interview. Yeah, yeah. So you have 10 to 15 minutes to talk about the next problem. If the interviewer decides to forego the last 5 minutes, if you have questions for him, he'll give you like 20, which is plenty of time to talk about you know how to do the next problem, which is you spent 20 minutes doing that. So
Hmm. Okay.
you see how it's like perfectly reasonable if you just increase your efficiency by even half.
Yeah. Yeah.
Like, it literally just cutting out.
Um.
It's just literally for you. You have the efficient. Is like being efficient at it and coming up with examples. In fact, let me show you how I would approach something like this.
Okay.
So, so for me, I would do exactly what you did first. Naive solution. Let me get something on the board. Let me think about it. I just do it like probably in about like 10, yeah, probably like 10 minutes. I'd probably say. Let's estimate. Now, when I look at a problem like this, I'm like, okay, well, I've exhausted my DFS solution. My DFS solution requires an external data structure. So the two
Hmm.
dimensions I can improve on is time complexity and space complexity. So which one is my option? So with let's take my time complexity first. I'm gonna have to basically look through every single node just to find the ancestor anyway. There's not really a way of going through it faster unless I was given that it's like sorted or something. Then I could probably do like a binary search. Search if sorted, or to get to order log n, right? Because that's the only thing faster than n. Or I can. The other
Yeah.
option is to not do as many passes, and or do not as many passes. So it's like kind of weird for me to figure out what the obvious one is, right? So space complex that leaves space complexity. So the best way for
Okay.
me to do it is to try and not store as many nodes. And the only way I can do that is if I can do it recursively and keep the information in place. Nice. And then looking at the situation that you had where you're comparing the path that you took, well, why don't I just eval at the common path instead of running the same path twice? This is at least what I'd be thinking so far. So
Okay.
after that, I'm like, okay, well, let me think about it recursively. Let me just figure out some kind of traversal. So that
Yeah. Yeah. I think that the one where you said why don't I just eval at the common path instead of running the same path twice? I think if I've like if that thought came to mind, I probably would have be a lot quicker. But that just didn't come to mind, and I was just kept thinking about like traversing through the whole thing.
do you remember what I said at the very beginning of the session about efficiency?
Um, at the very beginning, was it? Actually, no, I don't quite remember what.
The entire
Um,
interview game is about how efficient you are with your time,
hmm,
right? So
yeah.
shouldn't that also apply to your algorithm? How efficient can your algorithm be?
Okay.
And what is the best way to be efficient at your algorithm?
Go with like the quickest solution.
I mean, how do you
Yeah.
get there?
Yeah.
What is the easy one of the easiest ways to improve your efficiency?
Recognize the pattern. Is,
Even simpler.
uh, even simpler.
How about not doing the same work twice?
Okay. How
Yeah.
about not doing
Like
this?
I ask you to go to the store to get some milk, get some eggs, and then you drive to the store, get the milk, come back, drive back to the store, get the eggs, come back. Do you know how you can improve your efficiency on that? Grab the damn
Do it
milk and eggs
once.
first, and then just make only one trip. So you see, this literally just that's literally the only thing. It's just how efficient your algorithm is. And what you're doing
Okay,
here
yeah.
is you're running the same path. You're iterating through the tree in order to get the path to the node, and then you're iterating through that path again. That should be iterating. Hey, wait a minute. Why am I doing that work twice? That was my only insight. Why am I doing that work twice? Just how do I improve my efficiency?
Mm.
And in fact, even the insight up here, how do I improve my efficiency on the time? Well, I can either do not as many passes, or I can get to order log n. And my condition for getting to order log n is if I have some kind of binary search or some way of directing me to a particular side. But it's either hit or miss Boolean flag. So I have no choice but to check every single one. So the only other
Yep.
option is to not do as many passes with n. So to me, I'm just like, well, that's not immediately obvious as to how I don't do that, unless I, change
Mm.
up my, excuse me, change up my algorithm in some way. So I'll come back
Yep.
to this because it's not immediately obvious. The other, because I have another dimension I can go after, space. So I'll make this note. Not obvious how to improve space. I mean, try space. So why don't I evaluate? So then basically here's my traversal, right? So
Yep.
now I'm thinking, okay, so what are all my possible scenarios? So you have a few, right? You have let's say you found a node at left, and then you have R, and then visit R. So let's say you found a node here and node here, right?
Yeah.
So N1, N2. Doesn't matter. N1 and N2 are interchangeable. So in this case, then my common ancestor must be V. So then next one is if I am V N1, L, and then R N1, N2. Or, which is basically equivalent to if I have L N1, R, and then I have V. You would agree that these two are essentially equivalent. They're just
Yep.
flipped.
They're the same.
So, which means that in this case, it must be V. So, really, I'm only dealing with like two situations here. I think this, and then the other situation is that I only find one, right? It only finds one.
Mm.
Which is like, okay, well, there's no ancestor to be had here. So, return nothing. Whatever that looks like. So, in this case, my algorithm is going to look something like, if my V is equal to null, then return nothing. So I don't know what that state looks like, but let's try it out. So here, then I can visit my left and right nodes, right?
Yeah.
So then left equals to recurse, right equals to recurse, and then right, and then R, and then L. Okay, so then that means that I found all the nodes in like N1, N2, right? Let me add that case. So let's say I found it in N1/N2, and then I found nothing here. So then L, right? Or in this case, or it could be R. You understand the equivalence here. So then if both found in left, return left. Whatever that might look like.
Okay.
If both found right, return right. So whatever that might look like. Again, we'll just figure out what the state is later, but that and make that
Okay.
distinction. So then if left and this equals to a node equals to either node or right and this equals either node, then we return this because that covers this particular case, right?
Yeah.
So returns this. So now what exactly do I need to track here? So in this particular case, I need to know if did I find one node or two on the left in the children, right? Because here,
Yeah.
if I found both of them in the left side, then I know that there must be two nodes in here. If I found two nodes on the right side, I know that there must be two nodes in here. And then in this condition, I only found one node. So that's a distinguishing factor, right?
Yeah.
So then here, what I'm going to be returning is like this, probably like the state object, right? Which is going to have an int of number of nodes found, and then this would be like node common ancestor, because this would be left dot ancestor that's found, right dot ancestor is found, and then this is going to be the node. So then here, if both found, the condition for this is if both found if the state. So then state would be if state dot number of nodes found equals to 2. That would be if I found it. So then here, because now I have this state that I need to handle, okay, well now this needs to start returning state. So this is going to be state foo. I'm writing this very quickly, but hopefully you get the idea.
Yeah.
So now it's like, okay, well now I know that this is not going to be ancestor anymore. It's just going to be my states that I found. And then here I'm just going to have to craft a new state. New state that I found 2, and then I need to return this. Pretty simple, right?
Yeah.
And then I just have to figure out the empty state object. But notice how quickly I did that? It was like 10 minutes for pseudocode. And then if I do with what you just did, 5 minutes for the code, then it's
15. Yeah.
So then I would hit 30 minutes. Hopefully this makes sense.
Yeah. Helps a lot.
Yeah, I mean, like I definitely went back over and because I missed like one case, but you see like how quickly I was able to correct myself when I fucked up.
Yeah. Okay.
And you know what? And the reason why is
You already planned it out pretty well, so writing the code, like the pseudocode itself, wouldn't take too long.
yeah, like I have examples to go back to. Did I cover my ass? Did I cover every single fucking case? And then when I started writing, I realized, wait, I did not. And I mean, I kind of did it fast, but I would have double checked my examples. And once I realized, hey, I didn't cover every single example. Let me go back and make sure I planned everything. And I added that back in, like, oh, okay, well, it wasn't that bad. Da 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 da. And then I just translate that back to code. And it's very easy to see which one of these which one of these code snippets correspond to which case. And that right there already does a lot of communication to the interviewer, because, like, in my opinion, I think communication is totally overrated. You know why?
No, I don't know why exactly.
Because your design should already do all the speaking.
What? Okay, so when I was doing it, I wasn't quite sure if like the way I was communicating was okay, or was it so I know I struggled, but like aside from that, regardless of like how I did with the problem, how was my communication? Was I being silent for too long? Like
Silent or
so
being
yeah.
too long, it just means that you're slow. And most people just say, oh, go communicate, and then you'll be fine. And I think that's actually terrible, terrible advice. Communication just comes as a natural progression of train of thought. Like, look at this. Like, your naive's example. You don't really even have that much, you don't even have pseudocode here, but I totally understood exactly what you were talking about here. because you have like you have examples to go through, and then you just like you just walk me through it.
Yeah, I
And that
just
and
yeah,
that
it's just like yeah. Yeah, no, sorry. Sorry to cut you off. But yeah, it's just like a lot of like, a lot of articles like they always say like communicate what you're thinking, but then when I'm stuck, it's just like there's nothing to be talked about. And yeah, I just don't know if like if it's okay to be like silent for too long, but then yeah, I just gotta be faster on like figuring things out.
exactly, like the communication comes naturally if you ask yourself the right questions and you're asking the interviewer the right questions. You say,
Mm.
"Hey, I'm thinking about doing this, but the benefit of doing this is X, and doing the drawback of this is da." You know, and then from there the
Yeah.
conversation produces naturally because you're asking yourself the right questions, and then the interviewer will decide, "Hey, wait a minute, he's on the right track. Maybe I nudge him." But you only ever ask that and say that once you actually know what to ask and like your thought process is correct.
Mm.
So that's why I think communication is totally overrated. And even in production code, I think communication, like even in like a professional coding environment, I think communication
Yeah.
is way too overrated. Like, like let me give you an example here. This is getting into the more meta stuff, like the more professional side of things. Like, what's easier?
Okay.
Let's see. Uh, let's see. Boolean found a number in object O. Return O dot value instance. Something like this. Like, what do you think is easier to read?
Second one.
The second one? This one?
Wait, oh wait. No. Found number. Mm. Actually, the first one, just because the second one has a lot of like redundant code.
Yeah, like I mean, it's communicating for sure. You know this, but like I know that this is like a very silly and over exaggerated example, but there is a lot of code out there that looks pretty similar to this. Like if it's not with integers, it's going to be with some other state or enum that we make
Yeah,
ourselves. So
yeah, but I get what you mean with the example.
mhm.
Yeah.
Like your code and design should already speak volumes. It could speak more than what you ever could do. The only reason you communicate is so you can tell you what your train of thought is, but it should not be used to in lieu of like your actual good design.
Hmm.
And it means if you're silent, that means that you're potatoed. And I know people say, "Oh, just talk," but then you're talking, but nothing's coming out of your mouth, nothing significant. You know, you might as well just be talking about how the weather is today. So, do you have any other
Right.
questions about it?
Yeah. Um. No, I guess like so. Okay, so I didn't sound too like okay. So I guess communication wise, I wasn't as bad as I thought. Aside from being slow.
Yeah, you're literally just
Uh.
slow. You're again, communication is just a natural progression, is a natural effect of how prepared you are, how good you are at the problem.
Okay.
In fact,
Do
I'm gonna share with you this recording anyway, so you can listen to yourself.
okay. Yeah. Yeah. That would be great.